Good afternoon, everybody. My name is Charlie Nicklin. I'm the Chief Executive of IAgrE, and I'd like to thank you all for joining our July presentation today. I'd like to welcome back Chris Mann, who is the Chief Technology Officer at Bennamann Limited. Chris did a presentation at our conference last year on his work on fugitive methane capture from slurry lagoons in the dairy sector. This was coupled with a presentation on the methane-powered tractor from New Holland, which started production late last year. Chris has kindly agreed to update us on the project development and plans for future rollout in other ag areas and the waste sector. So just before Chris starts, as normal, you are all currently muted. And if you'd like to ask questions, please use the chat. And then at the end of the presentation, we can unmute you so you can ask in person. Okay, over to you, Chris.
Okay, so thanks everyone for coming and finding out again what we're up to at Bennamann. It's an incredibly busy period for us at the moment. Lots of exciting stuff going on, which I'll try and fill you in as much as possible. I guess the key thing down at the bottom there is a little logo from FPT, Fiat Powertrain. You'll see they've been working behind the scenes for us because our goal at Bennamann is to really take the farm completely off grid. And since the crisis in Ukraine, it's really become apparent how farming and hence food is actually reliant on the price of fossil fuel. So the energy independent farm is actually more important now because it's not just about energy, it's about the economics. It makes it economically independent from other factors, which has always been something that has been important for farming, but not necessarily apparent until the recent crisis. I'd like to point out another little logo on the bottom there, IAgrE. IAgrE is the International Fugitive Emissions Abatement Association, something that was founded by myself and Tim Fox, partly because of the lack of knowledge and understanding of fugitive emissions within the sector and other sectors, primarily to help people who put out emissions to help solve their problems and work together. I should say a lot of this work was funded by the European Union, and we're now part owned by Holland Industries. So we start with the cycle. What is it? Well, really, it starts with grass. Grass obviously has got fantastic photosynthesis properties that stores that energy. And we initially set out on our journey to look at capturing energy directly from grass using anaerobic digestion. But in the journey, we found that actually there's huge amounts of methane already being emitted to the environment once it's been eaten by a cow. And cows are great digesters of grass, but they also have a methanogenic stomach, so they're able to produce methane. And that makes the anaerobic digestion part of it really easy because it starts off anaerobic. So cow slurry is already anaerobic and it's already generating methane. You'll see that we developed a very special covered slurry lagoon to capture the methane that comes off the lagoon. I should say again, pointing out, the lagoon is a concentrator of that energy. So sunlight into grass goes into cows. What's not taken up by the cow ends up in the lagoon. And that's a great big concentrator. And I'll talk a little bit about why that's important later on when we talk about waste treatment as well, because it's another similar thing. All of that energy is going into one point where you can deal with it. From there, we end up with the biogas. We do some clever stuff with that. And actually, ultimately now we liquefy it. And the picture behind me is actually the core pieces of technology that we developed since our last talk, which is the mobile storage tank. That holds half a ton of liquid methane. On the over my right shoulder is the liquefaction plant. So this takes liquid nitrogen, runs it through fugitive methane and converts into liquid methane. I should say both these components are now operating normally at our farm, producing liquid methane. So this is a sustainable circular economy that we're trying to do. And the other thing that we're really trying to achieve is to use that energy locally. So capture it locally and then use it locally to people who can access that energy. And in doing so, we cut out a lot of the costs. So we've certainly cut out the middleman. A lot of the gas that we're producing on the farm is now being used on farm. The first Cornwall farm has a methane tractor on site and soon to be a generator as well. And if we do that, that cuts down on logistics costs. That solves half the problems. And then the way that we store it as a liquid allows us to then move it around as well. Because there's very low cost of the input, generally it's quite a profitable process. And this enables us to share that profit with the farmer. And typically we're achieving in most models that we have now quite a detailed return on investment model. We're looking at payback between 4 to 6 years, and then obviously 20 years plus income. But more importantly, as importantly, I should say, there's huge reduction in costs of the operation of the farm in terms of slurry movement, but also in terms of the artificial fertilizer that they require. And these are things you're going to have to be doing anyway soon, because you're going to have to meet with regulatory compliance regarding this clean air strategy and SAFO. There's also a lot of other operational benefits, because you reduce your need to rely on imported electricity, and also you free the farm from being power constrained. A lot of the small farms we find are running off single phase power, which means they're running diesel gensets already when they're milking cows. There's huge amounts of environmental benefit. I'll talk about that in a little bit, but typically we're seeing CO2 reduction 60% plus, and this really is a momentous change, particularly for dairy and other livestock, where they're seen as one of the main contributors to climate change. We're also seeing the benefits of soil health. This will take a little while to establish, but primarily this is because it frees the farmer up from that constant reliance on spreading slurry, not because he wants to get the best out of it, because he has to, because his lagoon is nearly full. We've also seen huge benefits in rainwater harvesting, and also in terms of soil compaction because of improved soil health. I've got two examples of slurry lagoons here. This is one on the left. This is a dairy lagoon. This has been there for 20 days. This is in the middle of February. These are big boils of biogas that are coming off. It's roughly a hectare across. Huge potential for capturing that methane, but obviously a real nuisance for people who live close to it in terms of pests and smells. And also it means that the farm doesn't really make the most benefit from it. That's for dairy. On the right-hand side, I had to go and see a man about a pig a few weeks ago, and this is a pig lagoon, absolutely the same. Similar amounts of methane probably coming off, slightly different the way that the slurry is harvested on the farm or captured on the farm and dealt with, but nevertheless, huge methane potential. And this is going to be really important going forwards, because it's that potential that the Bennamann model is starting to release. To give you an example, a typical dairy farm produces 6 times more fugitive methane than it can use. We collect that excess, sell it, and share the profit with the farmer. That's the basic model. And because it's fugitive, that would otherwise get into the environment, it's huge benefit. So one new Holland gas tractor running off fugitive methane is equivalent to taking just under 700 cars off the road. We're looking at, for a typical 150 head dairy farm, producing something around 40 tons of methane, and that's worth around about £10,000 to £15,000 in cash and operational savings to the farm. A lot of that savings comes in the form of benefits that we've yet to fully quantify, but from the sort of things that we're seeing on our first farms, it looks like those savings are likely to be true. Equivalent carbon saving is something like 3,500 tons. Methane, as we know now after the COP26, is one of the biggest contributors to climate change. IPC5, the fifth assessment report, puts it at 42%. I believe, I hadn't had a chance to check, that IPC6, the latest report, puts it closer to 48% of all climate change is going to be down to methane over the next 20 years. But there's one real big difference about methane, is that it's a global warming gas, but it's a fantastic fuel for internal combustion engines. And we at Bennamann believe that internal combustion engines are going to be around for some time yet. And I think other people in the sector are starting to see that's true, particularly as it's part of the solution. And it's technology that can come off the production line now, and it's ready. So in terms of capturing that fugitive methane, it offers an 86-fold benefit, a global warming potential benefit, over traditional carbon neutral feedstock where they're derived from biofuels. And because you capture it now, it's got the potential to slow down the early onset of global warming. So there's an opportunity here for really impacting or minimizing the impact of global warming over the next 10 to 20 years. People said to us, why are you different? What's the difference between yourself and the conventional natural gas and LNG sectors? And to be honest, I had to really think about it, and certainly the rest of our team had to think about it. And then we realized that what we've done is we've changed the way that liquid methane in particular is captured and managed. Typically, methane comes from natural gas. About 80% of a good gas field is methane. The rest of it's ethane, propane, butane, a lot of other nasties that have to be cleaned out. And that's a really complex process. So the first thing is we're dealing with a much simpler feedstock. It's typically biogas is going to be, certainly from dairy slurry, it's going to be mostly CO2 and methane, a small amount of water and a small amount of hydrogen sulfide. So we've removed a lot of those heavy hydrocarbons, which have to be taken out with complex processes. The other thing is we're not centralized, we're distributed. So there's 13,500 dairy farms in the UK. So we can think of those as 13,500 sources of methane rather than 1 or 2 big gas wellheads that then have to be served by a centralized processing plant. What we've done, if you look at these big plants and the LNG supply chain, it's all based on a supply and demand that has to be met. So the gas is coming out of the ground, you've got to process it and get it onto a ship at the same rate it's coming out. It's got to be used by the end market at the same rate. So you've got this continuous centralized supply, and they rely on a piped grid network, and it's just in time. And this is why we've seen this huge vulnerability to geopolitics, particularly with LNG, and also now with gas pipelines that could be turned off. LNG, because you can't simply increase the requirement if demand goes up, because you can't build more ships. And this makes it sensitive to fluctuations in supply and demand. And you can only access a limited global customer base. You can only access those people who've got connection to the gas grid, or alternatively the electric grid if it's primarily electrical power. So if we look at what we're doing, what we've actually done is we've decentralized it initially. That's the first thing. But then what we've also done is, because we've got a mobile processing plant, which is moved between sites, and we use that in conjunction with a storage of the raw biogas or partially clean biogas on site, we've also desynchronized it. We have the ability to store up to a month's worth of gas in the biogas storage of the lagoon. And we have the ability to turn up the plant when we need it and leave it there for a couple of days or 2 days or 1 day, depending on the customer's demand. So we've basically got a local aggregation distribution model, but it really does exploit this whole local biogas storage and process preparation, the rapid mobile nature of the biogas or the methane processing and liquefaction. And then we monitor the whole thing remotely using IoT. So we're using a centralized control and distribution logistics center. We can do that because we're using road transportation, not only for the aggregation, but also for the distribution sales. And this means we meet everybody. Anyone at the end of a road or a lane becomes a customer or a supplier. Because it's now distributed, any fluctuations of individual suppliers means that there's no risk to the whole network. Obviously, security of the network is really important, but pretty much we can access methane from wherever it is, no matter how remote it is, provided we can get to it by road. And we can also sell it to anyone, no matter where they are in the world, as long as we can get to it by road. Won't talk any more about the methane tractor, but it's here and now. This is now being produced, on a daily basis at Basildon. I was up there recently and pleased to see that these tractors are coming off. And this is starting to establish this whole methane supply requirement, which I'll talk a little bit about in the future, because there's now a requirement for compressed gas, and we're seeing that also with vehicles supplying Cornwall Council, which I'll show you in a bit. But there's also going to be a massive demand for liquid methane, because supplying heavy vehicles and higher power vehicles is going to be solved. That problem is going to be solved using liquid methane. So I did say earlier that one of the things that one of our partners has produced for us was this whole vision of taking the farm completely off grid, not just supplying the fuel for the tractor, but also supplying all the power for the farm. So as part of the Energy Independent Farm Projects, which is funded by the European Regional Development Fund, is we worked in conjunction with FPT to measure the power requirement of a typical dairy farm, and then design what effectively is the equivalent of a Prius, a hybrid generator. So this generator can either be off, it's fitted with a large battery, as you'll see in a minute, or it can run at high power and be boosted. So for those 2 to 3 hours of intense milking, where the farm really does require a lot of power, sorry, just apologies for that. So those high intense periods, this piece of equipment can supply what the farm needs. I won't play the whole video, but it gives you an idea. So this system is effectively a large battery. It's designed specifically for a dairy. It has a variable speed engine that runs on low pressure so that it meets the requirement of gensets globally. It has a very small turbocharged engine, which supplies up to 50 kilowatts of continuous power, but also has a 37.5 kilowatt engine. And it then has a digital power electronics. So this won't be the final product, but this is the product prototype that's going to be put onto a dairy farm in a couple of weeks' time. So it's got a number of modes. It uses a small engine. It's it's able to reduce the number of intervals that's required, but it can supply a very wide range of power using a combination of the battery and also the digital electronics. If you're not using any power at all, it can run purely off the battery. And then finally, this is the sort of vision for the complete farm. I should say we showcased this at the recent World Biogas Expo, and it was incredibly well received by farmers in general, but dairy farmers in particular, because this is a real issue. The one thing that's really unique about it is the ability to carry out a fast charge of an electric vehicle. So it's able to supply 37 kilowatt charge to a vehicle in less than an hour. But also it's able to take the whole farm off grid. So this gives you the 3-phase 400-volt supply up to 80 kVA. I really do think this is the future. This has now been delivered to Bennamann at China Earth, which I'll show you in a minute. And so together with this and the methane capture, you've now got the ability to truly take a farm off grid, powered entirely by its waste. Just to prove that this is now real. Oh, sorry, this is a little video that I'll show. This probably means I have to open up another window. But it does give you the sort of...
Welcome to Bennamann, a small, highly innovative Cornish company working with a major global partner, CNH Industrial, to deliver a...
Oh, pardon me.
I'm not receiving any sound.
Okay. Let me just see.
I don't think the video is running either. The clock isn't clicking up.
Okay, let me see if I can get... Okay. What do we do? We'll drop that. I don't know why that's not playing there, but the sound isn't coming. Okay, so one of the things that is really going to be exciting for us, and I'm sure other companies that want to get into this space, is the announcement of the Slurry Investment Fund, but also the Sustainable Farming Incentives, which was announced by George Eustace at the Devon County Show. I was lucky there to be there, and we've been briefing DEFRA on what we've been doing. And I should say that George is incredibly enthusiastic about it. And if you want to go to this link, which I can share afterwards, it gives you more information about this. But I think, this is the opportunity for farmers who've got issues with their slurry stores or want to replace their slurry stores to access a grant that covers up to 50%, I believe. The details haven't fully been announced yet, but this will be available in the autumn. So this gives farmers a way in, and obviously reduces that return on investment period. So what have we been doing in the meantime? We've been trying to prove out what we in Cornwall has been funded by the Cornwall Council in conjunction, in partnership with ourselves and Cormac. Cormac are the company that supply all of the services to the council, in demonstrating what we believe to be the first franchise based on fugitive methane capture and distribution. The first farm is now up and running at Trenance. It's been running and supplying significant amounts of gas that we've been supplying to Cormac, but also using in tractor trials here at the farm. The farmer himself has his own tractor, and as I say, the FBT solution will be going there in a couple of weeks' time and will be there for 3 months to capture data on its usage. So that means it will be the first farm. I should say that Trenance Farm had its carbon footprint assessed last year prior to this system going in, and it was 2,500 tonnes. The recent assessment is 500. So Trenance is now probably one of the lowest carbon footprint dairy farms, certainly in the UK, if not in Europe. Once we've demonstrated that capability for 6 farms, and this represents the first step of a franchise model, where we intend to roll it out globally with supported by CNH, using their distribution network and dealership. I should say, what I've got to show you here is a little short video. It shows you all of the elements of the independent farm on one site.
having over 80 times the...
Oh, not that one, sorry. So what you have here is the methane processing plant, methane tractor, and also the FPT hybrid hub, the smart hybrid hub. I should say the methane tractor is our workhorse. We use it all over the place, and it's absolutely great. It's one of the earlier prototypes, so it might not look quite normal to yourselves. I should say thank you to FPT. This project was carried out in parallel with everything else we're doing, with very little intervention from ourselves other than supplying them with a specification, and delivered on time just before the World Biogas Show. So where do we go from here? Well, if you've got an existing lagoon that is functional and meets the SAPO requirements and covers your needs, then if you fit this new product, which is going to be coming out towards the end of the year, the first product prototypes should be arriving in a couple of weeks here, and we'll be testing them on the lagoon. This is a floating biogas capturing system. As I say, part of our model relies on the fact that we store the biogas on site. So this not only keeps the rainwater off, by keeping the rainwater off, it gives you effectively in Cornwall at least about another 50% more storage on that lagoon. So you go from about 4 months storage for a typical SAPO designed lagoon to around about 6 months. This is designed to come in tessellated tiles, so we can cover up to quite large lagoons. The largest tile we'll be doing is a 20 by 20. And that will capture about a week's worth of gas from about a herd of 150 cows. So if you've got a lagoon which is 4 times that size, again, you can capture around about a month's worth of gas to store it on site. It comes with a biogas upgrading system, which effectively dries and removes the hydrogen sulfide from the gas that's captured underneath. It has a ballast strip around the bottom, which is filled with water, and it's held in contact with the surface of the lagoon by a small negative pressure to ensure that we don't get any air get into the system. The top of the surface of the cover is maintained as a concave, so it runs off into the middle, and then the center of each point is a rainwater takeoff well, where we can pump the water out, similar to our standard lagoon on the left-hand side. So this is for farms where you already have the ability to store the slurry, but you need to increase the capability to hold it and also cover your lagoons as you go into soon. This gives you a revenue stream. So typical paybacks on this are predicted to be between 2 to 3 years. What it also does is it means you've now got a viable supply of methane on site. So part of that, our business rollout plans will be to supply this as in a finance package with CNHi. There's something that can be purchased alongside a tractor, one of the methane tractors, but also hopefully can be financed through it and also through the slurry investment fund. Our traditional lagoon, which we now have 2 of, and I should say, I'll show you in a minute, we're making real progress in Cornwall with the remaining lagoons, is what we recommend for if you've got nothing in place already and you've got to go to the expense of digging a new lagoon or putting a new slurry store in place, then the additional cost of this warrants doing something along these lines because it has a payback compared to an open lagoon. It also means you can get away with a smaller lagoon, or you can increase your slurry store further from 6 months onwards. So these are the typical solutions that we're offering. The top new lagoon we're offering now, and we have a huge pipeline of farms that are interested in doing this. We're trying to cluster them in areas where we'll be able to service the gas collection demand, and we're starting to see a huge amount of demand for the cover on the right. I should say both of these lagoons are covered by patents and patent applications, which are in the process of going through. So how does the energy independent farm work? What are the benefits to the farmer? Well, and I say we nearly are at the point now where nothing leaves the farm. We're at a point where the only thing we're taking from the farm is the activated carbon filters. So we have a supplier that delivers them to the farm and takes them away, and they're dealt with responsibly and sustainably. But in terms of that, the wet slurry is passed into the lagoon from the milking shed. And in doing so, we immediately reduce the ammonia that would otherwise be emitted if it's standing in channels beneath the feet of the cows, and also reduces the NO2 pollution. A lot of the slurry investment fund is around the reduction of NO2 and ammonia, and of course we capture that anyway. So that's something if you can capture methane, then the methane gets held within it. One of the things we have noticed recently is the need to get that slurry into the lagoon as soon as possible, particularly in large dairy sheds. Slurry tends to remain in the channels for days, if not weeks, on its way out. The issue with that is it's losing ammonia all the time. So you'll be losing some of that NPK you need to retain will be lost to the air within the shed. It also creates a relatively unpleasant environment for the livestock. So one of the things that we're now starting to add have an add-on into the new farms that are coming online in the Cornwall Cancer Farm, and will retrofit into the existing farm, is the ability to take some fresh digestate from the lagoon, pump it up to the channels and empty those channels regularly, either every day or every couple of days, to make sure that all of the slurry gets into the lagoon as possible. And we believe this will help reduce your nitrogen requirement further. From there, the biogas is simply captured. We're not doing anything to enhance the production of the biogas. There's plenty of it coming off of open lagoons. We do move the foot treatment, or we're very careful about how much of the foot treatment goes into the lagoon, just because we're not quite certain yet as to how that will affect methane production, and also what it does to the digestate. We have come across farms that are using large amounts of copper sulfate, which is something that we'll be looking into going forwards as to how that's maintained. Currently, at the moment, the milking sheds use paper bedding, although we are looking at using other forms of recycled grass, and also recycled other materials that we're looking at using. So once that biogas has been captured by the lagoon, it's part processed and stored. That involves with each lagoon there's a small plant room which has a small compressor and a dryer, and also the activated carbon drum. So the raw biogas is taken from the base layer of the lagoon, dried, partially cleaned, so the hydrogen sulfide is removed, and then it's put back under the green gas cover. And it's stored there until it needs to be taken away. Typically, we're visiting the farms once every 5 to 7 days at the moment. It seems to be about right, which is roughly what we designed the system to do. So next, after the biogas has been captured, it needs to be processed. This is done at the moment primarily into compressed gas. That gas, we take the partially cleaned and dried biogas. We then strip out the remaining moisture, so it's incredibly dry. We separate out the bulk of the CO2. The remaining CO2 is unfortunately at the moment released to atmosphere. So that's something in the future we'll be doing, is being able to capture the CO2. But at the moment, our focus is on capturing as much of that methane as possible. It's then compressed, or now, as I just said, that we are liquefying as well, certainly at Chinoa, and then delivered to the customer or used on the farm. Top right, which now exists over my right-hand shoulder, is the first MST. You can see that holds 0.5 ton of liquid methane. That will become our primary moving tool for moving methane from the farm. It's incredibly energy dense as a liquid, so something like a 600-fold reduction in volume. Each one holds 0.5 ton at the moment. We'll be looking at moving up to 1 ton next year later on, and we can deliver that off-site to other users of the fuel. If it's left on site, we leave a reserve of gas for the farmer to use in his tractor, or soon to be in his hybrid hub. The slurry is then put back onto the soil. There is a way of enhancing the digestate. We've done some very early trials where we've taken that digestate, we've converted it from an anaerobic slurry digestate to an aerobic compost tea by injecting air and also a compost inoculum. An aerobic compost inoculum, and then that has been delivered primarily at the moment subsoiling to existing pastures. The farmer at Trinance is having great success in using his slurry, spreading it, measuring the NPK as he's spreading it. At the moment, I think he's seen something like a 2/3 reduction in the amount of NPK or nitrogen is required on the farm this year. So we expect to be improving that further as we go. I think the enhanced digestate is something that really does deserve a lot more effort, certainly more than we have the ability to put on at the moment. but it's something for the future. And I believe this is how farmers will go truly negative carbon in the future through soil sequestration of carbon and improving the soil health as well. There's two pictures there, one on the left, these are two cover crops, one applied with raw digestate, on the right applied with enhanced digestate. The one on the left into a maize stubble field, on the right into an existing herbal ley. The picture on the right was taken, I believe, about 4 weeks after the seeds were planted, and on the left about 8 weeks afterwards. So it's basically it's 4 weeks ahead, and also, of course, you've got all the cover crop as well that you're the actual pasture itself. From there, the slurry is finally, or the digestate, what's left of the digestate, can also be then, if there's sufficient fibre, and it can actually be recycled and used as bedding, or that's something that we haven't done yet. So before and after putting this onto a farm, I should say these are numbers that were generated by a consultant using the IPCC Assessment 5 report. As I say, it may have improved slightly since then because I believe the contribution of methane and slurry has increased. But for a typical 150 herd dairy farm, prior to putting on the Bennamann system and having a methane tractor, the CO2 output, the equivalent CO2 output of that was 4,500 tonnes. And as you can see of that, the primary contribution was from the slurry and actually from the enteric fermentation. I think there's still more work to understand that exact split. At the moment, they're attributing something like over 60% of the total methane emitted from a cow is from its slurry and manure, and about 30% from the remaining 30% from the actual enteric fermentation, so from its breath and from its rear end in the form of gas. So after the Bennamann system has been put on that farm, the calculations are now being backed up by measurement. We remove the bulk of the methane release from the slurry and the manure. We can use some of that methane in the power for the farm. You can also power the tractor, but you can look at those numbers, they're relatively small compared to the actual contribution for the methane, hence why we're actually focusing on the methane at the moment. And also we believe there's a reduction in the amount of NPK, and we'll be keeping a close eye on that. And the remaining energy is then passed on to customers. So when you look at the total sum, the farm output in this instance has gone from 4,400 tonnes per year to 1,600 tonnes per year. So that's a reduction of about 2,800 tonnes of carbon equivalent. 65% reduction in CO2e, and you can see 64% of that comes from the methane. The rest of it is from saving of CO2 from the reduction in diesel, equivalent to 140 UK household carbon footprints. And when you bear in mind there's 13,500 farms in the UK, then that could be a huge reduction of the overall country's carbon equivalent footprint. So ongoing projects at the moment where we are, as I said, the new build lagoon is now available. This is something that we're having huge amounts of interest from farms that have either lagoons that have to be replaced or insufficient lagoon structure. The retrofit cover is something we believe for those lagoons that are good, that can be reutilized with the ability to capture the gas and then pay for themselves. I should say the biocycle plant, we're now moving into continuous operation. So it's been used every day, I think, for the last 3 weeks. So we're getting to a point where we're working out what we need to do in the next one, and we're putting into process building 3 more of those as we speak right now. FPT have done a stunning job on delivering us the smart hybrid hub. So the farm can truly go off grid in terms of its power, not just its tractor fuel, but also its power. And one of the things that I haven't had a chance to talk about is off-grid EV charging. And this is something that our first system, we codename it the sauna, is actually ready to go. We've got the methane. We've been held up by the supply chain in the methane generator market, but we now have that in place. So over the next couple of months, you'll be seeing some press articles about how we're actually charging electric cars using fugitive emissions from cow slurry lagoons. And this gives us another market again. So at the moment, we're in that sort of critical build-up phase where we've got a lot of gas, we've got a lot of customers, but we've got to link the two and make sure those logistics work in between. Give you an idea of the projects that we've got on at the moment. Actually, probably shouldn't have that there, but we have the first farm is now fully live. It's been through a number of redesigns and improvements. We have a methane tractor on site that's being used continuously. Farm 2 is now covered. Actually, this photograph's out of date. That now has a cover on it, and Farm 3 will go live in Q4 this year as well. And we've been supplying fuel to Cormac since September last year, and we're now supplying, there'll be 12 more trucks in the country. 2 more trucks a month will be going on the road. So we're setting up a filling station at the Cormac Scuria headquarters, so that we can take the gas there and they can fill themselves. We've been supporting various New Holland methane tractor sales and also demonstrations around the country, including Glastonbury. As you should say, we're now in the process of bench testing the FPT hybrid hub, and we'll be taking forwards those improvements. So in terms of what it offers to farmers, what does the farmer get out of it? Well, first of all, it turns what has been a really big problem for farmers in the past, i.e. managing slurry, particularly with climate change. We're certainly seeing Cornwall very, very intense periods of rain, very difficult to predict, very difficult to manage. So we've turned that real problem into something which actually generates revenue for the farm. But it does that in 2 ways. Firstly, it supplies a cash share to the farmer, but more importantly, for many ways, it's the fuel and the energy that the farm can use, because these are now things that are becoming very, very volatile in terms of trying to plan for next year. We can offer stability in the cost of fuel and energy going forwards, and also in terms of reduced fertilizer, again, another product which is derived from fossil fuel. So this is the key thing. We're now working with New Holland on bigger tractors that will be able to reduce that energy reliance further. So in terms of contractor costs, hopefully bigger tractors will be able to run a fugitive methane as well in the future. And this means that for a dairy farmer and other farmers that rely on contractors, those contractor costs can also be resilient compared to the price of fossil fuel. In terms of energy independence, you are actually now producing a low-cost green energy on site. It's not something a farmer can do on their own. There's a huge amount of technology that's got into this. There's a huge amount of engineering knowledge, which we've developed in-house, but also now working with New Holland, which we've got to now take into production, and that's going to be the next big challenge, is rolling up. This makes the farmer at least protected from the market price. And when we think about it, every single thing we eat is reliant on fuel in one form or another, either fuel of the tractors or for heating hot houses that grow our tomatoes in the winter. So the ability to grow the fuel from waste, repurpose that waste and turn it into something that provides a farm energy shouldn't be underestimated. It also overcomes the grid limitations. What we've seen in our first Cornwall Council farm is they've been able to, with the confidence that they've got in the fact that they can have the power to increase their milking capability, they've rapidly expanded their herd. And that is a reduction in the cost it would have done if they'd had to go through the national grid, and also from a timescale point of view. So now, basically, this isn't an anaerobic digester. This is the covered slurry lagoon where we capture the gas. So there's no expensive technology or the need to export to grid now. We can monetize that methane by taking it away from the farm. As I said, in terms of the environmental benefits, there's the methane, which has a huge reduction of the emissions from the farm. One of the things we'll be doing very shortly is capturing the remaining CO2. And that, when you think about it, that really does turn the farm negative carbon, because unlike traditional ADs, where even if they captured the CO2, that would only render them neutral, because this would have been emitted from the slurry lagoon anyway. This now does make that farm negative. We've got reduced ammonia and NOx emissions as a matter of course. It's not something we've gone out because we seal the lagoon. All of that ammonia and NOx remains in the slurry. There's no need to remove it. Replacing the reliance on fossil fuels. One of the things that we think is going to be massive going forwards is the ability for the farmer now to focus on improving his soil health. And with some of the sustainable farming incentives, I think hand in hand, this really works well. So it gives the farmers that extra income and also extra time to focus on improving their soil health, which, let's face it, if it's not healthy soil, it's dirt. And this is something in the future I believe will be a great way to sequester carbon. We have huge amounts of water. It's not something we've really built into the model yet, but we're starting to see the ability to capture that clean water and harvest it is a huge, huge benefit to the farmer. There's also going to be a lot of waste heat coming off the FPT hybrid genset when we get out on the farm. So this is reduction in cost for heating water. And of course, meeting the regulatory compliance. This is a challenge. It's pretty clear to us in the UK what we've got to do. But as you go into France, Germany, everyone's got different rules. And so there's a huge exercise going on at the moment to understand what those rules will be when we roll this out abroad. And I believe I might have finished a bit early, but I think that's my last slide. Let me just check. Yeah, so I think I had one slide hidden, which I'll just unhide, because it is something that, so how does this approach transfer across to the wastewater sector? And well, at the moment, the wastewater sector has a huge issue with fugitive emissions of methane from its secondary anaerobic storage lagoons and tanks. At the moment, methane, the wastewater industry uses anaerobic digestion to remove a lot of the energy that's left in the human effluent. And when you think about it, that also contains things like fat from cooking and also lots of waste food. So there's a huge amount of energy that could be retained if it was able to be captured. At the moment, the answer is to use combined heat and power. And some of that heat is used in the sewage treatment sites to increase the rate of the methane production. But a lot of that waste heat is removed. If you visit any of these sectors, any of these sites, you'll find that there's constantly a stream of vehicles, heavy vehicles arriving at the site running on diesel. So it's ironic that really in the wastewater sector, one of the biggest costs for the people who supply is diesel, where actually there's all that fuel there. So we're actually actively working at the moment with South West Water, looking at how we can transfer some of the technology we've developed for agriculture directly into the wastewater. There's bound to be a few challenges. Gas probably isn't likely to be as clean as coming from Slough Lagoon, but nevertheless, eminently solvable problems. And this means instead of turning that gas into heat and electricity, we can turn it into vehicle grade fuel and make use of the renewable transport fuel certificate. And this can be then used to power the vehicles that are visiting the site, the water authority's own vehicles, but also supply electric chargers for local communities with the excess gas. The other thing is that we're looking now into the heavier market. So these are big vehicles in construction and in the transport sector. And at the moment, there aren't any real solutions for anything over about 4 tons, probably 2.5 tons, if you're honest, in terms of electric vehicles. And certainly hydrogen is so far out there that I think we have to have a solution before it's going to be available. So we've now got a position where we can actually start to move some of this technology and some of this methane capturing and processing equipment into the wastewater sector. And why are we going there first? Because again, it's the low-hanging fruit. It's where all of that human effluent ends up in one place, where we can deal with it in one place. And there's a lot of it, and there's a big problem to solve. So I think it's a classic example of where something developed in one sector has now been transferred over into another sector. And we're actually learning a huge amount from the wastewater sector, which will be transferring back into the agriculture sector. And I should say part of that's come out of our involvement with IAgrE. And we're also working with people in the oil and gas sector because there's a huge opportunity there. And I think that is it. It is.
Okay, thanks, Chris. We've got stacks of questions. I don't know if we're going to get through them all, but we'll try. We've got sort of 15 minutes or so. First question's from Tim Reynolds. If you want to unmute yourself, Tim.
Yes, Chris, great presentation. Thank you very much. I was questioning how feasible is it to capture the methane straight from the rumen, from the animals? Is that realistic?
Yeah, it is. Yeah, it is definitely. It's going to be more energy intense. One of the benefits of the covered Slough Lagoon is we actually don't do anything to it. You know, it's there, and it's only CO2 and it's methane primarily are the two constituents with a little bit of water and H2S. So the H2S is easily dealt with. If we're going to capture it from the air, first of all, we have to design the sheds right. Well, I guess the first thing we have to be is certain that there's actually enough there. One of the things that came up in one of the IAgrE meetings actually was how much methane is coming from the ruminant and how much is coming from its surroundings. Because obviously, if it's in a shed that's got existing channels that are full of slurry, fresh slurry in general, that will be giving off a lot of methane. So you've got to make sure that those tests really are showing how much is coming off from the animal and how much is coming from the slurry. Let's assume it's 30%. So if it is, then we need to design the sheds correctly. Methane's lighter than air, so there's going to be a natural tendency to rise. And then it's going to take some pretty intensive gas processing or alternatively flaring. So it depends what we're trying to achieve. I think the challenge is going to be how much is there, how costly is it to be for the equipment versus capturing it and then maybe flaring it or doing something else with it just to deal with the pollution issue. But in principle, yeah, cryogenic technology, which is what we specialize in, can be used for doing that. It's more challenging because we thought about it. It's definitely doable.
Thank you.
Mike Whiting.
Hi.
No.
Just a quick question. You mentioned about the EU funding at the beginning of the presentation.
Yep.
We've now obviously left the EU. So what happens to those funding streams?
So the ones that we won are still in progress. So we have 2 projects that's still ongoing. The Energy Independent Farm is probably going to close this year, and we've spent all the money that we were given, and more, I should say. It was great getting us where we are. The second one is the off-grid EV charger. So that stream will run for another year because we won it. Going forward, I don't believe there is any replacement directly for it. In Cornwall, it has been muted that all of the funding it would have got will be got in other forms. But how much of that will come to agriculture, I don't know. But I should say the sustainable farming incentive, from what I've seen, looks hand in hand with what we're doing. The Slow Investment Fund looks like a really good option going forwards. But of course, it's coming in tranches, depending on the farmer's uptake. But I do, from what I've seen of it, it does look encouraging, and it does. Certainly the changes we've seen on Chinoeth Farm, with the way the farmers moved from an intensive dairy into a more sort of like a mixed farm, it's definitely doable and probably as profitable as well. But I think the jury's still out on it, but I don't think there's any more European funding coming this way.
Thanks, Chris.
Okay, Bob Watson.
Yeah, I've been working on earthline lagoons for quite a while and speccing them up for people. I've had about 50 phone calls in the last year or two. When I run the scale model to look at ammonia, big problems for anyone, generally 2.5 kilometers from a triple SI, because the ammonia can affect mosses and lichens.
Yeah.
And this is interfering with planning applications. It's not the 2027 covering thing, it's imminent. So this is of great interest because I'm getting 4 out of 5 farmers at the moment will have huge problems with the planners on account of 4% lower PCs than Natural England has set, which they're now dropping to 1% lower PCs. So in the southwest, nearly everybody who wants to put in a store will have ammonia issues and mitigation to think about. So this is a really important side thing on the methane.
Yeah, thanks, Bob. I mean, it does raise, so in terms of the option 1, which is our sort of like full installation, it's completely sealed. I mean, it's quite remarkable. I think you've been there, Bob, the lack of smell and pests and stuff. So but it's obviously more expensive than putting in a cover on an earth-based lagoon. One of the outstanding questions for us is how much we go to capture the remaining bit. If we design the lagoon to fit our cover, and also and forget the perimeter, the smaller bit around the outside, we are going to lose some gas. We are going to lose a bit of ammonia, but you're down in the less than 10%, my guess is number. So we are talking to the Environment Agency right at this moment, actually, to see whether or not they can look at the new emissions from the option 2 cover and see if that means that the triple SI requirement can be not removed, but basically adapted to take that into account. So yeah, they're working very close. I should say we really great thanks to the Environment Agency, been really closely working with us all the way through, because you can imagine it's not just the environmental issue, there's also some health and safety things that we've had to take on board, and making sure that we can manage it on a day-to-day basis with minimum intervention has been really key.
Okay.
Thanks, Bob.
Hey, Mark Andrews.
Thank you very much, Chris. It's a great presentation. Just sort of logistics. So I wonder, how often is the lagoon actually emptied physically? Get something in there and dig it out and push it on the field.
Good question. So the big lagoon, Chinoeth, our first one, has been there for now 12 years. So, and it's never been emptied. But it has a very similar. We don't have stirrers in there. Think of it as a great big jacuzzi. There's 4 jets pointing up onto each side. Yeah. There's got to be sediment in there. You'd be mad to believe that it's a perfectly clean bottom. We designed it so you can get in there. Our guys are trained in breathing equipment, so we would have to empty it completely, probably flush it through with water or digestate, give it a good stir, get as much out as possible, and then lift up the covers. But to go in, which is doable, we talked about it already. I think every 5 years until we know for certain what sort of timescales are required. And I do believe, I think Bob might be able to answer in SAPO, I think there's actually a requirement to inspect certain types of lagoons every so many years. So we've never had to do it in China Earth. We've got leak detection systems put in place so that if there is a leak and it's getting into the watercourse, we detect it straight away. And we still don't know really the full lifetime of we've used the best possible liners that we can find on the market. So there are examples of that liner, which have been there since the 80s, full exposure to the sunlight, and they still maintain their suppleness. I can talk all day about liners if you like, but we've looked into it.
Fantastic. That's fantastic news, though, isn't it?
Yeah, that's a good question. We with the option one, we don't recommend using sand because for that reason, it's going to get in there. Even with the best sand traps, you're going to get some in there, and there's going to be a build up. Hence the use of paper bedding, which our farmers are finding to be really good. And those that are using sand, certainly in the southwest, I think there's a limited supply. There's already people saying it's not sustainable because of the amount that's been taken from the estuaries and such. So I think sand is probably. So other than that, I think I'd answer probably once every 5 years, and we're probably going to have to do it on ours at some point over the next couple of years, just to see what's happening. But what we're trying to do at the moment is get as many lagoons up and running and as stably up and running and get the data as soon as possible. And that's our challenge for the next 12 months, to be honest. And get all those customers, because we have to keep the farmer happy. We also have to keep the customer happy at the other end. The people who are buying the gas. And if you run out of gas and they've just bought a fleet of 12 trucks, they're not too happy. So we've got challenges at both ends, but we're getting there.
Yeah, and that cover, I presume, lasts a similar sort of period.
Yeah. So there's three covers. There's the bottom cover, seals the ground. There's the floating cover, which is a similar material but thinner because it's out of the elements. And then the gas cover is the same gas cover you'll see on a lot of all the digesters used in Germany. So I mean, they're pretty tough stuff. We are now also working with IAgrE. We're starting to get to a point where we can see any leaks. So if the cover starts to leak or if there's holes in it, there's cameras around, and there's also new detection equipment, which is something we're working with Cornwall Council on as well. So yeah, go ahead.
Oh yeah, that's fantastic. And the final question is: you're taking off hydrogen sulfides.
Yeah.
What do you do with that?
So at the moment, that's the only thing that leaves the farm. That's our non-part of the circular economy. So we have a number of suppliers that offer a service where they deliver it fresh, or they deliver it. It starts off fresh, and then it gets taken away in the drums. They have to be certified, so it's transported back to their processing plant where they're recycled, and they can do. Then it's mixed with fresh and then brought back. So you can do that about 5 times. Eventually, it's ending up in landfill. Hence the desire for us to solve that problem. We do have a number of solutions. There's a few technical solutions that can be introduced, but our priority is to get that safety, and that's a big factor that people don't take into account. We've no longer got this toxic gas. Every year there are farmers that die, going down into slurry stores when they shouldn't. It's not very nice gas.
Yeah. Thank you. That's a great answer. Thank you.
John Boydell.
Yes, particularly interested in what happens to all the fluid that you take out when you empty the lagoon.
Okay, so firstly, so all we're removing when we take out the methane and the water vapor and the CO2 is the carbon from the plant and the hydrogen. So there's nothing other than leaves other than carbon and hydrogen, and a small amount of oxygen in the water, and then hydrogen sulfide. So what's left is basically what would ordinarily be in a slow lagoon. It's just there's a lot less of it. So this means that typically the lagoon will hold 6 months, which is the new requirement now from the Environment Agency. It's spread as normal digestate currently. What I didn't have a chance to talk about was you can then post-treat that digestate aerobically. You can introduce an aerobic strain of bacteria from a compost, and then that can be injected directly into the soil to give you a seeding compound. And that's something that's looking to be very, very successful. So if you spread it on the soil, you should be using a dribble bar. You should be using the moment of doing subsoil injection, so that you're not spreading and losing the ammonia. So does that answer your question, John?
Yes, thank you very much. It was the sheer volume that concerned me, because you're talking millions of gallons, surely.
Absolutely, yeah. The big lagoons, 4,500, 5,000 cubic meters. I don't know what that is in gallons, but it's a big lagoon. That was originally enough for 300 cows, sized in an MVZ, with 4 months of storage. And since putting the cover on, we've now got, because we're keeping all the rainwater out, you've got 6 months of storage.
It's still a major logistical exercise to distribute all that. Would you use all that fluid on the material farm?
Absolutely, yeah. So on a pasture-based dairy farm at Trenance, they literally drained it of everything between March and probably a couple of weeks ago. Of course, what you've got to remember, it's constantly being filled as well. So the jury's still out. So it's not like you empty it and then it's empty for a month, because every day there's two milkings going on in the shed. So whilst in the summer the amount of slurry production goes down, what we haven't ascertained yet is whether there's a drop in the gas production, because obviously it's warmer, so it's producing gas quicker. And even so, there's a trade-off somewhere. But whatever that trade-off is, you've only got 2/3 of the amount of slurry to spread that you had before. And this means the farm, and you've got that big window of time, so the farmer will spread it when the soil's dry and he needs it for his crop, so he can time it. And that makes life a lot easier.
At the other end of the scale, do you ever get a situation where the lagoons are overfull, where they overtop?
Touch wood, not yet. No, there's a extra space level that's not taken into account in the calculation for the volume. It's the same as an earth bank lagoon, but so far we've never had a full one. No. Doesn't say you can't.
Yeah, lovely.
I think one of the key things on that though is we are very careful with all the farms you go to make sure all of their roofs, all of that rainwater is directed away from the slurry, so it doesn't get pulled into the same. Because otherwise, if you've got a lot of rainwater coming off a big farm, then that will fill up the lagoon very, very quickly. So that's really key, that rainwater handling on all these dairy farms is very important.
Very good, thank you.
Okay, we've probably got time for one more question. Then if people want to stay on after the call, I'm sure Chris will probably answer some other questions.
Absolutely.
Tim Chayman, do you want to ask the final question?
Yeah, thanks, Chris. And I'm staying out of video because I've got limited bandwidth at the moment. But yeah, I'm a novice in this, so I've learned as much in the last few minutes as probably answering my question. But what happens to the continuity of supply on a farm when you're emptying the lagoon? But if that is only once in 5 years, I don't suppose that's a big issue.
No, we do. Oh no, we don't. We don't empty the lagoon. We empty the lagoon is continuously being emptied throughout the spreading season, which for us now is from the end of March right the way through to, I think it's the end of September. So you've got a 6-month window when you're not supposed to spread. So the farmer's constantly taking out some of the digestate and putting on the fields. Right. And there will be a big rush in the first couple of months. The 5 years is when we're looking at any sediment that's going to end up in the bottom. So there's bound to be some sand or grit that's scraped up with the slurry, will slowly build up on the bottom of the lagoon. Now, whether that's a problem, it becomes a problem if it takes up a significant volume of the lagoon, because it's obviously offsetting the amount of slurry you can put in it. But as long as it doesn't block the pipes and it doesn't do anything other than that, then there's no reason why we should really need to empty it. But unfortunately, the only way to really find out how much is in there is to literally take the covers off and go and have a look. And that's a huge safety exercise, which we've done. Part of the challenge in this was actually health and safety. So all of our operators, they're all fully trained in breathing equipment, working in confined spaces and stuff like that. So there will be a point in time, probably next year, when we will probably open up one of the lagoons. Of course, when we do that, we lose methane production, and it has to be empty. So we're sort of waiting for the opportune moment. But no, the gas production we expect to fluctuate throughout the year, and it's a case of how much does it fluctuate. At the end of the winter, the lagoon's full, but it's cold, so it tends to be producing less gas. At the end of the summer, it's full and warm, so we expect it to be putting out more. So we're probably expecting to see a dip around springtime and then an increase. The key thing for us, which we haven't really fully appreciated yet, is I said that at Chinoearth we have literally a 1 month's capacity of methane, which is about 2 tons of liquid methane once it's converted. So in the summer when there's no wind and in the winter when there's no wind and it's dark, we have the ability to keep supplying fuel indefinitely. So provided we've got enough processing capability, we can keep providing fuel to those that have got a lack of energy. And I think this is a real key thing for biomethane. It's not about solving the whole problem of renewable energy. It's about filling the gap. And believe it or not, there's only about 4 days in a year when there isn't enough wind and solar to sort of like supplement the existing gas and nuclear demand. So where we come in is being able to supply a lot of energy over a short period of time and have that stored up ready to go when necessary. So there's a logistics issue with that, but actually I think that's probably one of the real benefits. These big heavy vehicles, heavy power requirements, and long-term storage of energy.
Thanks very much, Chris. Yeah, thank you.
Okay, so we're about on an hour, so want to just draw it to a close. As I mentioned, we can stay on a little bit longer, hopefully, just to answer the remaining questions. But I'd just like to say thank you so much to Chris for giving us an update. Excellent presentation on where the project's gone. It's fantastic to hear the story as we did starting at the conference last year. Really interesting. You can tell that by the amount of questions we've got as well. I'm sure everybody found it really interesting. It's a great project that's going on in the UK as well. So thank you to everybody for joining us today. And now our next lecture is on the 9th of August, I believe. It's not published yet, and we'll be joined by IAgrE member Will Chewer, who is going to talk to us about his work with anaerobic digester plants. He should be watching this presentation, actually. So all that's left to say is thanks again for everybody for joining, and see you next time. Bye-bye.